Hi everyone, and welcome back to my YouTube channel. So today we have an interesting podcast on the topic trends in NLP, and we have Mr. Ivan Bilan here with me in this particular podcast. And I don't think I have to introduce Mr. Ivan to the data science community. He has been a known face in this particular industry for quite some time. And thanks a lot, Ivan, for joining me in this podcast.
Thank you for inviting. I'm excited to be here.
Thanks. So I have a couple of questions for you today, and let me start by, yeah. So it's been some time, and do you have any favorite NLP language task in your mind when it comes to the first task, basically, or like if there is a question like, okay, which is your favorite task basically to perform?
Yeah, sure. I think my favorite one would be aspect-based sentiment analysis. So this is something I worked on for a couple of years, and it's much more complicated than regular sentiment analysis because you need to extract the relevant phrase out of the sentence, and then also to classify it to some category or class. This is something I've did for a while at a company called Trust You, where we were analyzing hotel reviews and restaurant reviews, and we basically, we had like 200 classes or something like that, where we really did a very, very much fine-grained aspect-based sentiment analysis task. Also, another layer of complexity there was that we actually did this for more than 20 languages, which was also quite interesting.
Great. That's great to know, actually. So yeah, so this question, like, what is the direction do you think, like, where all of this is actually heading to?
Yeah, that's an interesting one. I think there are two possibilities now. One, we just keep building bigger and bigger language models and hope we sort of don't hit the limit there, and they kind of work. Another possibility is, of course, which I would prefer, is that we start thinking a bit more about the linguistics part of NLP and try to actually integrate it more strongly into the language models and make sure that these language models actually understand the structure of language and how it works, and not just learn from what they saw in a massive amount of data set.
Great. So yeah, so uh, this is something like so basically, when did you start actually like working towards NLP in specific in your career actually?
Yeah, actually, my in academia still, I studied computational linguistics, and that is basically a field that is very specifically, about NLP. It's a sort of a mix of computer science, data science, and linguistics. And right from the get-go there, I worked on some basic NLP tasks like tokenization and things like that. And it was a while back that we did this first in Perl, which is like a scripting language that was quite like used for NLP back then, and then eventually we of course moved into Python, and now almost everything is sort of Python based. So yeah, like I'm very grateful to my sort of academic background here. I studied here in Munich, in Germany, at the LMU. Worked with a lot of prominent NLP professors there as well, and I've learned a lot from there. And then from like my first year already was working in the field as a sort of working student.
Great to know. So yeah, like according to you, what is the most toughest aspect when you deal with these kind of tasks basically?
Yeah, interesting one. So there's quite a few things, right? We could talk about sort of bringing the actual model to production. I think that's very complicated part of it. But I think the sort of looking at NLP itself, I think the big issue we haven't solved yet is multilinguality, right? Like most of the NLP tasks that we worked on are sort of fine-tuned for English, right? And I saw it firsthand when I was working with more than 20 languages. It's when you worked with very complicated languages like Japanese or Thai, like for example, Asian languages or Arabic languages, you see how little in terms of resources there actually is out there compared to English. That's like the the hardest part. We had to rebuild many things from scratch. We had to build even basic things like tokenization, for example, for Thai language, where we worked with Thai. Thai is very complex language that doesn't have any delimiters of words, like there's no space, there's no full stop, sentences, words all together. So we had to actually train our own model for tokenization, for example. So like these basic things are not there for many languages.
True. I agree actually. So, yeah. So since you are actually working towards the production side, like what are the main hurdles actually when it comes to like when we start from the scratch and actually turning it into a production grade solution?
Yeah. So I mean, usually where you start is kind of try to build up the pipeline itself, right? You train some language or like fine tune language model for your task, for example. You make it work with the data that you have. So like first hurdle is collecting good quality data, right? Because you really need a lot of good quality labeled data for a proper fine tuning. Like these days, you could, for some tasks you can get away without that much labeled data, right? But it's still like one of the things that you really need to spend time on, really need to iterate on the data set that you get and improve it. Then the next part is like usually the training part, you don't really care how much time it takes, right? You can run it for a few days, whatever. But where the problem comes is inference time, right? Because if you want to put the model and your pipeline into production, you want the prediction to be fast, right? Like you don't want the user to wait 30 seconds for your model to produce a label or something like that. And that's where you start really tinkering with the pipeline itself and trying to make it run fast and make sure the inference is fast enough. And then the last bit is the sort of productionizing the model itself, right? Where do you store it? How do you serve it to the client, right? What kind of tooling do you use there? And there are quite a few tools you can use these days, but it's still very complex task, right? To put everything into the cloud, or do you use some of your own frameworks? And it's I think largely still an unsolved issue, but there's a lot of progress that has been made so far.
True. Yeah. So a few of the topics on this part actually, like so first one, like since you have seen the evolution of this NLP, how it progressed actually, what what is the importance of transfer learning, and do you think like it will still continue over some period of time?
Yeah, for sure. I think transfer learning really sort of allowed for lots of things. Like, lots of startups have really like sprung up when this transfer learning was more available, right? I remember maybe 2013 where we had Word2Vec, which is kind of not exactly transfer learning, but that has already propelled the NLP world, and then you started seeing more and more sort of production grade NLP products. Then I think when sort of Transformer and BERT came out, that has exploded even more, right? Because now it's easier to solve a very complex NLP task by just taking BERT or T5 and gathering some specific data for your task and then fine tuning it on your task, right? All you need to do there is basically get some label data. You'll need some hardware, some GPUs to fine tune either BERT or T5, but it's you do not need the massive amount of compute power to train BERT from scratch, for example, right? At least for English, right? I've heard actually examples where for other languages there is no specific BERT model, for example, for some language, and then people have to train it from scratch, and then they have to gather a lot of data, and then they need a lot of compute. But you still do it once, and if everyone actually open sources that model, in that language, then everyone benefits, and not just everyone, but also the sort of environment, right? I guess we'll talk about that aspect as well.
Sure. So and it's very interesting that like a lot of companies open source their models actually in specific domains, and it's like most widely used actually nowadays. And
Yeah.
yeah, like some of the aspects you actually touched upon. So when it comes to a problem where like we are actually training a NLP model, like anyway we will be right now will be actually using some existing pre-trained architectures to actually proceed with the thing. And as the hurdle actually like comes to the platform tools and the scaling part. So how do you see where actually we are at, or what is the stage where we are at this particular point?
Yeah, I think when it comes to tools and platforms, there are like quite a few ones you can use for like hosting the model itself and then serving it to the clients. Like I think there's a lot to choose from in terms of platforms and tools, where we still sort of a bit backwards, I would say, in monitoring, right? There are a lot of monitoring tools, but I think that still there's a lot that can be done for NLP specifically. I think they work better now for vision models or for like general data science tasks, but not specifically for NLP. And I think there we can do a lot more, like track the data drift, track user behavior drift and things like that. And another aspect that is still like I'd say very rudimentary is in terms of testing. Like the question is, how do we test these language models properly? And I think the last year and this year there has been a lot of work done in that. Like there was this new framework released called Checklist, where you do something called behavioral testing, or now they call it adaptive testing, where you really make sure to generate a lot of examples to test your model on, right? And this you do not just to see how good of a quality of the results are, but also to see if there's any bias, right? Because bias is another problem that's still also not really solved. So right now you have to do a lot of manual steps to write these tests and sort of work with them. I hope the industry works more on sort of automating this and creating more tools around it as well.
Cool. And on the production part, actually, like, do you think right now I think most of the companies prefer cloud services actually, and yeah, and there'll be some custom solutions which companies provide. So, like, do you think that the cloud service actually cater the real purpose of this in terms of production grade solution?
Yeah, I think there are quite a few. I mean, of course, a good example is Hugging Face, right? They have the Hugging Face inference API and Model Hub and many things you can use there. There's also a lot of things that you can build yourself with AWS on Kubernetes. A lot of companies I see use Kubernetes, for example, for that. There are different platforms. There are platforms that give you like automate as many things as possible, like SageMaker, right? Where there's many steps that are already done for you. If you want something more specific and more catered to what you try to do, you can just go still in the cloud, but sort of build it yourself, as I said, like with Kubernetes, for example, in AWS or Azure or GCP. There are many options here. I rarely these days see companies or startups that like do it from their on-premise servers, right? That is almost not happening anymore. What I see sometimes is that it's cheaper put it in the office just to run to train and like run experiments, because that is definitely cheaper. Like you can plug it in and run experiments for weeks, and that will cost you less than running the experiments in the cloud. But where cloud, like the pros of the cloud is that when you host it actually and then it does inference for you, it's so much easier. Like you don't have to think about downtimes and maintaining your servers and so on. That's where the cloud is actually super helpful.
Great, great. Yeah, that's actually true, and we have been experienced a lot in terms of production actually. And the next block, it's talking about the mega models actually, like from like okay, we can forget BERT. Now it comes the
Mhm.
next phase actually in terms of mega
Yeah.
models. So what is your count on it actually?
Yeah, the mega language models. Yeah, I mean, quite a few things that we can talk about here. I think first, um, this is a sort of a huge, like a massive progress for NLP, right? These models, they do show that with more compute, you can actually achieve more. Um, this is a good and a bad thing, right? It's good because we see that we're still not at the limit. We can train even bigger models and see what they will be capable of. But the trade-off is now that um, only like bigger corporations can use these more and more, right? Like let's say when a few years ago, this was okay to just run stuff on your laptop, right? You could train even BERT you could fit into a laptop, right? With some distilled BERT, for example. Now that's not possible anymore, right? You cannot fine tune GPT-3 on your laptop and things like that. So now like we're losing a bit because the big corp is now has more of a monopoly on these things. But at least they are, most of them at least are open sourced. There's also there's a lot of effort by the community itself to also even rebuild models that are not open source. Like GPT-3 itself is, closed source. You can only use it through API. But there's a group called Luther AI or Euler AI, depending on pronunciation, where they are trying to rebuild GPT-3, and they had some success with a model called GPT-J and GPT-Neo. It's like smaller versions of GPT-3 that that are pretty good, not as good as GPT-3, but you can potentially fit them into like a PC with a GPU, with one GPU, right? And then can do inference with them. So yeah, I mean, as I said, like there are trade-offs. It's good to see that we are, achieving new things. I hope we maybe like pause for a bit, rethink it. Next, do we keep on, training bigger and bigger models, or do we try to think about how to, make them still a bit smaller but as effective as like GPT-3, for example?
Yeah, so my next question actually was about it basically. So, like recently we heard the news from NVIDIA, which they have trained a mega model, Megatron, and
Yeah.
it is it is actually exponentially big in terms of the parameters, 530 basically. So, yeah,
Yeah,
this,
yeah. This actually there's a new one that I think this came out like a week or two ago. It's from Alibaba,
yeah,
and they say they trained the model with 1 trillion parameters, and they call it M6. And they actually, so it's not open source yet, and we don't know the specific details. But what we know is that it's 1 trillion parameters, but it's much more effective in terms of what hardware you need to train it. Right? They say it's like 1/100th of compute power needed for GPT-3, so it's much less. They trained it on 500 GPU cluster, which is still a lot, but it's not as much as what we use for GPT-3. Whereas for GPT-3, OpenAI used like 10,000 GPU cluster on Azure or something like that. So like we kind of, I think this is a move in the right direction. We are still growing the number of parameters, but we are now thinking more about how to make this model faster and sort of smaller in size and easier to train. And like I've seen a similar graph also for computer vision, where it's also going up in terms of like layers, right? I don't know, the newest ResNet probably has like hundreds of layers. But there are also sort of alternative solutions. There is something called ParNet. A ParNet is like a non-deep neural network. It only has 10 layers for computer vision. So it's much smaller, but it's effectively has the sort of performance in terms of quality on par with ResNet. So I would like to see something like that for NLP as well, where you have less parameters, you train it faster, but the quality is still the same. And like my best guess would be maybe this is the time to think about linguistics actually, and try to put it like more like combine it more with these massive language models.
My next question, actually, like couple of points here. So we spoke a lot about the mega models and the advancements in this field. So there are quite some things where we lack in terms of explainability and in an ethical aspect. So like, what do you consider, like in NLP? Are we considering AI ethics in terms of any projects or like any solution which we generally build?
Yeah, definitely. I think there's now more and more interest in this. So I know, for example, OpenAI now has hired a team of sort of ethics advocates for AI, right? That work on this topic. I know, for example, Hugging Face has now hired Margaret Mitchell, who is one of the authors of the paper about stochastic parrots. So yes, I think the companies are thinking more and more about this. And this is very important because we need to make it visible that this is still a problem, and we need to search for solutions. I think a good example is IBM Watson. I've read before that IBM Watson was sort of promised to be sort of a new AI tool that can be used in healthcare extensively, but it was maybe a good tool, but the doctors just didn't trust it because it was like a black box for them. They didn't know what, they just did not want to use it because they didn't know how that AI came to a conclusion. And I think that's probably something that will keep happening with AI, and especially with NLP, if we do not think about how to make everything more explainable, how to not build black boxes, right? How to help users understand how something came to a conclusion. And few things, just on a like rudimentary level, what you could do is just to make it visible to users that the output is generated by AI. Like this is one of like UX things you can do, where next to a label you have a sort of a tooltip that says this was generated by AI, and this is this AI is 90% sure about this, right? You give some prompt to the user that really helps a bit to understand the context of the result. But we need to do a lot more. We need to just really show how that model came to a conclusion. What I like, for example, about Hugging Face again on the Model Hub, what they try to do is they add a lot of information for each language model that they host. Like they have this idea of model cards where they show, for example, I think you can rank it by CO2 output, or you can rank it by what kind of data has been used to train that model. Like on for what languages does this model work, right? And things like that. This is a step in the right direction. And what we need to do more is to think more actively about how we can combat bias, for example. And there's one idea I've heard from I think Emily Bender, who's a linguistics professor, is to do more in terms of debiasing the data sets that we have. So what does that mean? Is like we look at we really analyze the data that we use, and we make sure to remove examples that are biased, or to add examples to sort of counteract the bias, and just really work with the data set itself, and make sure it's inclusive, make sure ideally it's also cross-lingual, right, so that it works not just for English, and just really work more actively on improving the data itself, and then how we use it in the AI.
Correct. Yeah, that's true. So yeah, actually, I really like the model cards in Hugging Face. Actually, it gives us the complete details on what exactly the model is, what is the data it's trained, and all those things, which is pretty transparent actually in a way. And I recently like the feature they have given for CO2 emission actually. So
Right.
so yeah, Code Carbon is doing a very great job actually. So we track the training emissions actually, and we post it there. So it's really great to have that particular measure there actually. So when it comes to open sourcing in these kind of models actually, like it's always a trade-off, because large players can easily adapt that particular thing, or it's like, okay, if there is a small player and they open source the thing, and soon it is actually being pushed by a large player basically. So that kind of a difference always exists. So like ideally it's a question, okay, whether we need to open source an AI module, or whether
Yeah.
we just have to provide the model as an output, or model as a service basically. So what is your take on open sourcing an AI service actually?
Yeah, that's a good question. I'm a big proponent of open sourcing. I think that really helps, not just in terms of models, but also tooling. Like if you look at companies like Hugging Face, Rasa's, Explosion AI with Spacey, like you really see those tools started like really small, and they would not have been as successful if they have not been open sourced, because the community has added so much to it, right? And that's one of the reasons why these companies have grown so fast, is with the help of the community itself. And I think that's the same case for AI models, right? If you open source the AI model, yes, someone will take it and maybe use it for for revenue purposes, but ideally they will improve it in some way, and then give back to the community as well. There's a small tweak they did, and they merge it back to the GitHub repo or something like that. That's already helping a lot, right? And this, like, through these small pieces, I think we can really improve the AI models. Of course, there are probably companies that have some really good AI language models that have not been open source. It's hard to say now, right? And maybe they are used. Maybe they are even better than what we have. So it's hard to know. I think these companies probably think it's like proprietary stuff, and they maybe want to patent it or something like that. But I would say it's a bit of a false thinking, because they will stagnate. They will be stuck with this model for a while, create more technical debt for themselves. Instead, they could open source it, let the community find bugs, fix issues, and then just be integrated back.
True. I agree actually. I agree to that particular point. So yeah, my last question actually, it comes to the sustainable AI piece. So like everything should actually go to a sustainable way, or like it should be built in a sustainable approach actually. So do you think like the current way of training or the current way of implementing these kind of models are actually branching towards a sustainability perspective?
Yeah, in some way. I mean, I think this sustainability topic has sort of been more and more important since about 2018, 2019, right? There was this great paper called Green AI that was, actually exploring this in more detail. The first step to being more sustainable is actually reporting. You have a paper for some AI conference, and I think there should be a step where your paper is not admitted if you do not calculate how much CO2 it takes to train your model, something like that. This is first step, to just make it visible first, right? But then maybe based on that, we can do more estimations and see, how much of CO2 emissions actually come from these AI models. And I think that this has already been done in a few papers. But that's like the first step. And then the second one is, of course, thinking more about how do we make these models more effective? How do we make them train for less time, and just really use less compute in general? So yeah.
True.
Let's see.
Yeah.
Right.
Let's see.
I think we're moving in the right direction, but yeah, I hope something more actionable will come out of this soon.
Great. Yeah, since everyone has actually been kind of keen to actually implement in this kind of approach. So I think like something concrete will actually definitely pop up in a later time.
Yeah.
Yeah.
Yeah, for sure.
And that covers all my questions actually for today. And thanks a lot, Ivan,
Great.
for actually answering all my questions and like explaining your experiences in this particular domain. And thanks a lot, Ivan, for spending time with us.
Yeah. No problem. Thank you so much for inviting me. This was a lot of fun, and I hope your community likes this episode as well.
Sure. Thanks a lot, guys, and have a nice day. Thank you.
Great. Bye, everyone.